Hello, my name is Ray Ko, and today we will be going over some practice problems on Dalton's law of partial pressures. So what is Dalton's law of partial pressures? It's a fairly intuitive concept. Basically, all the partial pressures inside a rigid flask, all the pressures added up will equal the total pressure. And so it's a fairly basic concept, and we're just going to reinforce the idea with some quick practice problems. Okay, a rigid flask contains 0.13 atmospheres of H2, 0.32 atmospheres of CO2, and 300 millimeters of mercury of H2O vapor. What is the total pressure of the flask? And so using Dalton's law of partial pressures, we just add all of these up and we should get the right answer. So we just plug that into a calculator and we would get this problem wrong. See if you can pause the video and find out what the mistake here is. Okay, so the mistake isn't with the actual idea itself. If all of these were atmospheres, this would be the correct equation to solve. However, since this is in millimeters per mercury, we have to convert it into atmospheres, or we can convert these other two into millimeters per mercury, but personally, I would rather convert everything into atmospheres. So we just divide this by 760, and we should get the total pressure. And adding everything up, we get PT is equal to 0.84. Don't forget to put units, atmospheres. Next problem. A total pressure of a flask containing only H2 and CO2 is 1.3 atmospheres. If H2 has a partial pressure of 0.31 atmospheres, what is the partial pressure of CO2? Okay, so in this case, we are given the total pressure. So 1.3 minus 0.31, because this is the partial pressure of H2, and in order to find the partial pressure of CO2, all we have to do is subtract the total pressure by the partial pressure of H2. And so this is a fairly simple problem. We don't even need a calculator for this. It's just going to be 0.99 atm. All right, next problem. That was quite easy. A rigid flask contains equal moles of H2 and CO2 at STP. What is the partial pressure of H2 if the rigid flask has a volume of 3.0 liters? So here we have STP. So we need to know what this means. STP basically means standard temperature and pressure. And so this is 0 degrees Celsius and 1 atm. Now we have to be careful here because 0 degrees Celsius turns into 273 Kelvin. So we have to keep that in mind. So we have to find the number of moles, and we're given liters. We should use Pivnerd. So if you looked at my previous video on Pivnerd ideal gas problems, I suggest you to check that out if you do not know what I'm talking about. If you are familiar with the Pivnerd equation, we'll just continue on. So STP1 multiplied by 3 liters is equal to the number of moles, which is one we try to solve for, by 0.082. This is the gas constant. Again, it's covered in my previous video. And 273. Looks good. Now we just solve for n. N will equal 0. So n will equal, let's just solve for n before we do anything. So n equals, sorry about my equal sign, 0.15. Let's see if we can, there we go, 0.15 moles. Now, we aren't done here. We do have to, and this is rounded by the way. We aren't done here. As we can see, it contains equal moles of H2 and CO2. Now using Dalton's law of partial pressures, we can easily find the partial pressure of H2 but simply by dividing this by 2. And so don't round it like I did here. Just take what the calculator gave you and divide that answer by 2, and you will get 0.77 atm. So Dalton's law of partial pressure, fairly simple concept. Hopefully, if you had difficulty in understanding, you are enlightened, for lack of a better term. So thank you for watching, and have a good day.